Alright, this is Mr. Holsey of 8 Squared's Officially Understood Science, and today we're going to be looking at the different types of galaxies. So galaxies are huge clusters of hundreds of billions of stars, and it's estimated that there are hundreds of billions of galaxies in the observable universe alone. And these are the major features of the universe, which began forming a few 100 million years after the Big Bang, once things had cooled down enough to allow for these galaxies to form. Now, there are three major types of galaxies that we're going to be talking about: elliptical, spiral, and irregular. And we're going to kind of go in reverse age order. You can actually tell a lot about a galaxy just by looking at it. So let's start taking a look first with ellipticals. So this is an elliptical galaxy. It is fairly spread out like a disk. It is nice and flat and stuff like that. So there are different versions of elliptical galaxies. You have ones like this. It could also be almost like a ball, but they are very straightforward. So like I said, they're circular to a narrow ellipse, and these are actually the oldest galaxies and evolve from spiral galaxies. So the stars that we find in these kinds of galaxies tend to be older stars and also lower mass. So the question becomes, what is the importance of this lower mass? So when it comes to lower mass stars, and we'll have a video on stars, lower mass stars tend to not go supernova. And supernovas are how gases and heavier elements are spread out through the universe. And so these low mass stars tend to not go supernova, and they also live a lot longer. And so these stars not going supernova means that these galaxies are going to contain very low dust or gas because they're all being used up. And so in a way, elliptical galaxies are very stable galaxies. Now they do make up about 1/3 of all the galaxies and contain and are going to be a very prominent feature. The next type of galaxy we're going to look at is the spiral. So spirals are really easy to grasp by their name. They have big long tendrils and things like that. Now these galaxies are shaped like flattened discs, like ellipses, but they have long arms that spiral out, and they evolve from what we call irregular galaxies. Now the stars here are a bit more mixed. We have a kind of a combination of young stars and old stars. So we have low mass stars, like in the elliptical, and this would be like our sun is a low mass star. And then we have high mass stars. So the big thing about high mass stars is they do go supernova. And this process of supernovas will spread out gases and dust. So in comparison, there's lots of gases and dust in a spiral galaxy. We can see examples of that, like the Horsehead Nebula, or one of my favorites, the Pillars of Creation, where we can just see tons of star formation going on. And the last type of galaxy is the irregular galaxy. So these are going to have no definite shape. They come in a large variety of shapes. They are the youngest galaxies, and this is what the proto-galaxies of the early universe would have resembled. Now, the stars here are going to the majority of stars are typically going to be high mass stars. We're going to see a lot of supernova, and these are going to be typically younger stars. Think about high mass stars. Besides going supernova, these stars have a short lifespan. And so this is just going to be, these types of galaxies are going to be very chaotic, very, very dynamic, changing all the time. Now, sometimes we can find these near large spiral galaxies who can be distorting their shape due to gravity. And so that's been a quick recap of the different types of galaxies that can be found in the universe. Of course, these aren't all of them. These are the three major categories, and there are subgroups in between. Another thing to keep in mind is that we believe at the heart of every galaxy there is a supermassive black hole. And so that's something really, really interesting to keep in mind. Even though it's shining really bright, it's because there's a lot of mass near that black hole, lots of stars. Well, that's going to do it for today. This has been Mr. Holsey of A Squared's Officially Understood Science. Remember to hit that like, share, and subscribe, and hit the bell notification to know when we post new tutorials. Catch you next time.